Hey, we've got this problem and it says determine whether or not the relation here represents y as a function of x. So to do this, what we're going to do is we're going to move everything to one side and solve y in terms of x and see what we get. So we start with negative 8x plus 4y equals 1. All right. I'm going to add 8x to both sides, trying to get y by itself, and I get 4y equals 1 plus 8x. All right. Now I'm gonna divide by 4 on both sides, and I get y is equal to 1/4 plus 8 over 4x, which is 1/4 plus 2x. All right. So to determine whether or not this is a function or not, we need to ask ourselves, for every element of the domain, do we get one and only one element of the range? So I'm just going to test a couple of points here and see what I get. X, f of x. I'm going to test -2, -1, 0, 1, and 2 and see what I get. If I plug in -2, y as a function of x, I'm going to have f of -2 is equal to 1/4 plus 2 times -2, which is 1/4 plus -4, which is -3 3/4. I'm going to write this as like a bigger fraction. It's going to be 15 over 4, -15 over 4. All right. If I plug in -1, I'm going to get 1/4 plus 2 times -1, which is 1/4 plus -2, which is -1 3/4, which is -7 over 4. Alrighty, so I'm just checking to make sure that I get only one element of the range. For each x that I plug in, I'm only going to get one element in my range, which is working so far. When I plugged in -2, I only got one value. When I plugged in -1, I got one value. f of 0, I'm going to get 1/4 plus 2 times 0, which is just 1/4. I'm still just getting one value. f of 1, 1/4 plus 2 times 1, which is 2 1/4, which is 9/4. All right, and then f of 2, that's my last one. That's going to be 1/4 plus 4, which is 4 1/4, which is 17 over 4. Alrighty, so looking at this right here, I see that every element that I put in, I get one value. I'm not getting plus or minus anything. I'm not getting some weird multiple numbers. I'm only getting one value. This -2 goes to -15 over 4. -1 goes to -7 over 4. And for all of these, I just get one value. So this is a function. We could also look at the graph of this. The graph looks something like this. It would have, so it was f of x equals 1/4 plus 2x. This is my y-intercept. This is my slope. So it intersects the y-axis at 1/4. And our slope tells us it's going to look something like this. This is a very rough drawing, but it looks something like this. And it's kind of squiggly, but it works. Then from here, what we can do is our vertical line test. So imagine we draw a line that looks like this. And we move that line along the x-axis. So it's moving this way and this way. And every single point just has one intersection with this line. So this is a function. This is called the vertical line test. If this wasn't a function, what would happen is when this vertical line intersects our function, it would intersect it at 2 points. But here that doesn't happen. It just intersects at 1 point. So this is a function.